we go to example number 12. Solve the equation and check your answer. E raised to 2x minus 3 e raised to x plus 2 is equal to 0. So this type of equation involves e as a certain base raised to the certain exponents to x and x. So what we're going to do here is, first, we have to let our e into what do you call this, a variable. So let us say our ex is equal to u. Now you could choose any variable. You could choose u, you could choose v, w, as long as you are comfortable with the variable. So in this case, I chose u, and this has nothing to do with, it doesn't have any effect whether you choose any other variables instead of u. Okay, so having our e raised to x as u, then we will have e raised to 2x will be ex 2, am I correct? Because 2x is equal to an exponent raised to another exponent, okay? Or an exponent an exponent multiplied to another exponent. And then this one becomes 3 ex, okay, 3ex plus 2 is equal to 0. Now in this case, we could now make our e raised to x substituted into u. So this will be u squared minus 3u plus 2 is equal to 0. Notice that our new equation now is similar to a quadratic equation, or an equation in quadratic form. Therefore, we could use some techniques of solving, like factoring or the quadratic formula. So in this case, I want to use the factoring. Okay, so if I factor this quadratic form, I should be able to get u minus 2 and u minus 1. And then, so equating each of the individual factors to 0, that will give me u minus 2 okay, u minus 2 is equal to 0, and on this side I would have u minus 1 is equal to 0, and u here would be equal to 2, but in here your u will be equal to 1. And then our e raised to x, now we go back to the original form of our u, which is e raised to x. So this e raised to x now becomes 2, and e raised to x on the other side is 1. And how do I solve for x then? Now to solve for x, you can see that if we this is a property of a common or a natural logarithm, that for you to be able to get x, you must be able to multiply ln to both of the expressions. So ln of e raised to x is equal to ln of 2. And this will give me an expression which is now x. So x is equal to ln of 2. And on the other side, I will have ln of e raised to x is equal to 1. So, I'm sorry, that's not equal to 1. It's ln of 1. Okay. So, this form here will just give me x is equal to ln of 1. And x is equal to ln of 1 is equal to x is equal to 0. Okay? And in this case, my x is equal to ln of 2, or correspondingly, solving in a calculator, I will get my x as 0.6931 rounded off to the nearest tenth of a thousandth. Okay, so these are our solutions, and these numbers comprise my solution set. Okay, we have 0 and 0.6931. Okay, but are our solutions really the correct solutions for this equation? Well, we have to check it, and if we do get a consistent comparison, okay, or a consistent value out of using those solutions, then we will have a correct solution, or a correct solution set. So in this case, our x, or our solution set, comprises of x is equal to 0 and x is equal to ln of, what was that? Ln of 2. Okay, so now the original equation is e2x okay, it's e raised to 2x minus 3 raised to, or 3e raised to x plus 2 is equal to 0. Now we're going to use x is equal to 0 and determine if using this solution for this equation would give us a valid argument. So let us say e raised to 2 raised to 0, or 2 times 0, minus 3e raised to 0 plus 2, is it equal to 0? That's a question. So e raised to 2 times 0 is just e raised to 0, am I correct? Minus 3e raised to 0 plus 2, is it equal to 0? Okay. Now e raised to 0 is just 1, because anything that is raised to 0 is valued as 1. Minus, so this other 1 here, this other e raised to 0 is again 1. So minus 3 times 1 plus 2 is it equal to 0? Let us see. So 1 minus 3 plus 2, is it equal to 0? Indeed, 0 is equal to 0. So now we have proven that the solution x is equal to 0 is valid for the given equation. So therefore, x is equal to 0 is a solution. Okay? Now checking is required, because sometimes you get some values of x which are not actually applicable as a solution for the given equation. So we have to be very careful about verifying whether the value that we get from a certain equation really is a consistent or a valid solution for the given equation. Okay, so now let us use x is equal to ln of 2 as a solution. Okay, and this is equal to 0.6931. Okay, so 0.6931 when rounded off to the nearest tenth of a thousandth. Okay, now we have to use it in the original equation. So this will give me e raised to 2 times 2 ln of, or e raised to 2 ln of 2 minus 3e raised to ln of 2 plus 2 is it equal to 0? Let us see. E raised to 2 ln of 2 minus 3 e ln of 2 plus 2, is it equal to 0? Okay. This will give me e squared times e ln of 2 minus 3 times e ln of 2 plus 2 is equal to 0. Or I think we have some mistake in here, in this part. Okay? This should actually be e raised to ln of 2 times 2. Okay? And we know from the property of the natural logarithm that when e is raised to an ln, then the corresponding value is 2. And we are talking about the property e raised to ln of x will just be equal to x. So in this case, we have 2 raised to 2 minus 3, this becomes 2 also, times 2 plus 2 is equal to 0. Now is it equal to 0? So 4 minus 6 plus 2, is it equal to 0? Okay, it seems like our argument is valid. So this is indeed equal to 0. Therefore, x is equal to ln of 2 is a solution, which makes both of the computed values as solutions of the given original equation e raised to 2x minus 3ex plus 2 is equal to 0.